Now we're going to do a little more with histograms. Okay, so more with histograms. Remember that, and we can include the bar charts here, but I just want to look at how we're trying to use these, or what we're trying to see. So histograms, the idea here is that in this I want to think about distributions. Okay, and the first distributions we want to think about are populations. Now, when I start talking about these particular histograms and distributions and so forth, what I'm going to do is I'm going to look at relative frequency. Okay, up till now with the one video, we looked at just the frequency. So, there were 10 things, there were 11 things, there were 22 things, there were 5 things. Okay, so that's frequency. Relative frequency is what percentage of the overall are we talking about. And so let's keep it real simple, is that if I have a population of dice, and I'm rolling well, let's make it even simpler than that. Let's go with a coin. I can flip a coin, and now if I want to talk about the population of possible things that could happen when I could flip a coin, my population consists, I guess, of either heads or tails. I'm going to have those types of objects in my population, and so, well, and we'd expect with a fair coin, right, that we'd have 50% heads and 50% tails. And in this case, the case of flipping a coin, in a population like that, then in that case it really does make sense to talk about a relative frequency, because you want to think about, well, what do my possible outcomes look like relative to each other? Because if I just say I'm going to flip a coin, if you think of, okay, I'm going to flip the coin once, well, if I only flip it once, I can either get a heads or a tails. I can't get both, but the population I'm sampling from, so I'm flipping the coin once, that's a sample of what the coin could do. When I sample it, I'll either get a heads or a tails, but the population itself is kind of half heads, half tails, and I guess I could call it just 1/2 and think of it as a number, not a percentage or a relative frequency. But that's just what it is. It's a relative frequency. It's the percentage of the population that's represented by each of those things. And so in that case, it really would be a bar chart, I guess, not a histogram, because heads or tails, right? That's categorical. But so when I flip this coin, right? If I think of heads and I think of tails, then I would expect my bar chart to be the same size as far as my population, right? And I'd use a relative frequency, and we'll put this at 1/2 or 50%. So that's what my population looks like. Okay, and so if I do this, if I flip the coin, I would expect to see a heads half the time and tails half the time. Okay, and we see that. Now, if I flip 2 coins, now, and I can change this to numerical by, instead of talking about either heads or tails, I could have talked about the number of, I guess the way I have that one written, the number of tails. And in that case, then, if I did this, I would do something, I could either have 0 tails or 1 tail, but it would still look the same here at 1/2. Okay, so I could have 0 tails or 1 tail. Now if I flip 2 coins, number of tails or number of heads, it's symmetric because, you know, if I have, you know, however many tails I have minus that, you know, the supplement of that or the complement of that in heads. So, you know, I went with numbers of tails up here because I had gone heads, tails, so I want to go 0, 1. So if I switch now, you know, okay, numbers of heads with 2 coins, I could have 0, 1, or 2. And that's my population. So, you know, up here, my population in numbers of tails was 0 or 1. My population in numbers of heads was 0 or 1. Same thing here, flip 2 coins, I can get either 0, 1, or 2 heads. So that's my population. And I could ask, well, you know, how likely is it that I get those? And let's think of what could happen. And we kind of talk about these things called equally likely outcomes. And so I could get, to get 0 heads, I got tails, tails. To get 1 head, I either got heads on 1 coin, tails on the other, or tails on 1 and heads on the other. And to get 2 heads, I had to get heads, heads. Now, so you see each of these are possible flips, and each one is the same likeliness, because I flipped these 2 coins, and one of those 4 things happen. So here you see that's 1/4 of the time. These 2 make 2/4 of the time, because that's 1, you know, so this is 0 heads, 1 head, and then 2 heads, and this is 1/4 of the time. So now my population here would be, if I call that 0, that 1, and that 2, you know, at this point, again, as I say, bar charts are probably best, but you can't, you know, you can use a histogram, and let's see, so if this is 1, 2, and 1, right? So that's 25%, that's 50%, that's 25%, 25, 50, 25, or 1/4, 2/4. So I could make these, well, that should be twice as big, so we'll go about that high, and like that. So there is the population of the coins. They look like that, and it really doesn't matter if I flip 2 coins just once or I flip 2 coins a million times, but I'm talking about flipping 2 coins. My population, I expect to see here, this is 1/4, and up here is 1/2. And so I can look at my population this way. And so I can do it as a relative frequency. And we would tend to do that if we have something more theoretical, like, oh, I'm talking about flipping coins or picking a card out of a deck, so to speak, or something like that. And so you know, rolling a die. So you know, if I talk about rolling a 6-sided die, then, you know, I would expect I could get a 1, 2, 3, 4, 5, or 6, each equal numbers of times, and so that population You know, if that's 1, 2, 3, 4, 5, 6, that population would look like this. And again, you see, I don't really care that is a height of 1/6 in some ways. I mean, what I notice about this population is everything happens equally. That wasn't true up here with heads and tails as far as number of heads. I would expect to get one head here twice as often as either 0 heads or 2 heads. Or one head occurs as much as 0 or 2 heads put together. And so I'm looking at the population and I'm using a bar chart or a histogram to help me understand that relative frequency of how often I should see things if I sample them. So if I roll a die 4 times, then I could get the numbers 1 through 6, and here's a sample from that population of rolling the die 4 times. And in my sample, what I might get is that maybe I got a 1, a 3, a 4, and a 6, like that, and I rolled it 4 times. I got each of those once. Now, actually, that'd be great. You know, if I did that, that would be kind of what I might expect in rolling a die 4 times, because I would kind of expect to see each of these numbers the same amount of times. Now, that's sample 1. Sample 2, I could roll a die 4 times, and I could have gotten a 1. I could have gotten a 1, and then a 4 and a 5. You know, so you put those together. I got those twice, and that once, and that once. And certainly that could happen. I mean, you know, you roll a die, you could get that same number twice. You could get it twice in a row, or just maybe twice in the whole thing. But now this sample, notice the first sample looked sort of like the original distribution. So I can, as we're talking about these histograms and bar charts and populations versus samples. So see, there is my population for rolling a die. You know, what I would expect to see. I would expect to see 1, 2, 3, 4, 5, and 6, each equal numbers of times. Now here, if I roll it 4 times, I can't possibly get exactly that distribution. So here's 1, 2, 3, 4, 5, 6. I will not get exactly that same bar chart. Can't if I only roll it 4 times, because there are 6 numbers. So in this case, I got that, that one, and that one. Now, in this case, though, 1, 2, 3, 4, 5, 6, and I've got 2 here, and none for any of these 2 or 3, but then 1 for those. And there's my, you know, here's a sample distribution. And so up here was a population distribution. So again, my population distribution. And that's either theoretical in the sense of like rolling dice or something like that, or it truly is, if you looked at your whole population, what would you see? Versus if I go out and I do a survey, something like a sample or whatever, or I do an experiment and I look at, you know, I bring some people in, or I work with some plants or something like that. But if I use any sample, see, I don't expect my sample distribution to look quite exactly like my population distribution. It looks similar in that both of these down here are about, the best I would expect. I mean, this first one, since I only roll 4, I can only get 4 different numbers, and I did. And so, up to my population and how I'm sampling and so forth, it looked pretty good. The sample 2 here, well, really, it still looks pretty good. I mean, in that I have 2 things here for the 1. Yeah, I mean, I might get some repeats, but on the whole, everything's about the same height. That's where this word "about," I mean, it really is. It's an iffy sort of word. But as I look at things, considering what I've done, I've only rolled a die 4 times. Looks pretty good. So those are some sample distributions. Okay, now we're gonna, I guess we'll cut that because we're over 15 minutes already. So, so here was a little more on histograms and bar charts and distributions. And we've got a bit more yet to talk about with distributions.